a function of y, right? So if the y over here that I'm going to do in yellow moves, the y prime or the y bar will shift likewise. Okay, so the area will change. So the a prime is the area, is a defined area. And y max is equal to c and is equal to h over 2. Okay, and then b, okay, b for this case is the thickness. Okay, now this is based if and only if Vy is in this direction. Wait, later on I'll shift Vy. Okay, so let's find the first moment of area first. So the first moment of area, right? So Q. Now the first moment of area is going to be about the z-axis, right? Because this is the axis, that is the centroid when Vy is in that direction, and is equal to a y bar. Okay, it's equal to a y bar, right? Why y bar? Because the y is in that direction over there, right? So when you write this out, so this define the first moment of area about the zz axis, okay, and then the y bar is the perpendicular distance right for the area.
Eugene, I think you're muted.
Okay, am I muted now? Hello, can you hear me?
I can hear you.
Yeah.
You can hear me? Right. Well, how long was I muted?
For like 5 seconds.
Okay. Hey, I'm so grateful for you guys telling me. Okay, I do thank yours. I'm so, as I say, I'm so grateful. Okay, so when I mute, tell me, please. Okay, don't leave me in the dark. Okay, it's not a very good sensation leaving me in the dark. Right. So okay, I think I have to explain again. So we call it first moment of area is because of what? When we take moment is equal to force multiplied by what? Perpendicular distance. First moment of area means we take the area multiplied by the perpendicular distance. That's why we call it first moment of area. Okay. Now, this is with respect to your what? To your direction of your Vy. Now I'm going to do something, okay, different. I'm going to get the shear force now to be acting in the Z direction now. Okay, so we're going to act in the Z direction now. So copy, bring it this side, right? Okay. So before I go on, right, for this case, the thickness T is equal to what? B. Okay. So the axis of interest is always acting perpendicular. Yes or no? Right? So the geometry that is perpendicular, that is your thickness. Okay. Now, what if now? Okay. What if now our shear force is now acting in the what? In the z direction now. Okay. So when it's acting in the z direction, it will touch this surface first, and then the area of interest becomes this direction that I'm doing in red now. Okay. Then the distance from here to here is my z, and then if this is my centroid, okay, that will be my what? Z bar. Okay. So now what we are interested is what? The first moment of area in which direction now? So we want to find out Qy is equal to the area Z bar. Okay. So now for this case is the first moment of area about the y-axis, right? And your z now, okay, so this is again our perpendicular distance. Right? Now the thickness now, right? So the thickness is this thickness because this geometry is perpendicular, right? This geometry over here is perpendicular to the Vx. Okay, so this is your thickness now, and you define your thickness, which is perpendicular to the applied shear force. So now your thickness over here now, your T is equal to what? It's equal to 2C, or it's equal to what? H now. So you see the difference now. Okay. So it all depend, right? It all depend on how your shear force direction is acting. As I say, we are in a 3D world. Later on, when nearly the end of this course, you will do this, okay? And you will have shear force acting both in the y and in the z direction, or acting in your x and your y direction. Okay, so you have to get this really concise and really clear, or not you'll make a lot of mistake. Now, question so far, anyone? No? Okay, so I understand. For now,
Hello?
this, yes.
What about shearing strain? Is it the same as shearing stress?
No, strain, there's no unit. Okay, strain is the change of angles in terms of shear, while stress is in megapascal or psi. It's not the same. The only
Okay.
way is related. The only way that is related is on a stress strain curve. Okay,
Thank you.
thank you. So this is your thickness now. Okay. Now, then the next term I like to introduce you is I. Okay, I like to introduce you to the I. So I is the what? Second moment of area. Okay, so I'm also still going to use the same diagram. Let me get rid of this first. Okay, so I'm still going to use the same diagram. So if, right, your shear force is in the y direction again, right? When it's in your y direction, right, in your y direction, you have to take the z axis. Okay, the perpendicular axis of your Vy is Z. Okay, so now we are going to look at our, so we are going to look for, so Vy is perpendicular okay, I need more space. So Vy is perpendicular. Hey, I can't spell today. Perpendicular to the z-axis, right? So when this is the case, the z you have to do is we have to now find izz. Okay, we have to find izz. So second moment of zz. So second moment of izz. So this the direction that is parallel to the axis in them shading in yellow. Any geometry is known as the width, and any geometry that is perpendicular to the yellow highlighted line, this is our depth. So for this case, izz, the width, so the formula is width multiplied by depth cube divided by what? Divided by 12. So the width for this case is b. The depth over here is equal to h or 2c. Okay, either is equal to h cube divided by 12. Okay, right? So because Vy is in a vertical direction, it intercepts the ZZ axis in a perpendicular way. That's why you have to take IZZ. Okay. So now, if we were to flip this around again, okay, we'll do the other direction. Now, this is your what? If this is your VZ, right? It intersect the perpendicular distance, and now this is your what? Now this is your y axis. The perpendicular distance is now axis is now the y, right? So what you're interested is your IYY. So IYY now. So this case, anything that so anything that's parallel to the y axis, this is the width, and perpendicular is your what? It's your depth. So for this case, the formula did not change. So it's going to width multiplied by depth cube divided by 12. So this will be, so the width is equal to 2c or is equal to h. And the depth is b cube divided by what? 12. Right? So you can see whether you take IYY or IZZ, it all dependent on your what? Your shear force direction. Okay. So now, what does this actually means? Okay, what does this actually? So if you look at the shear now, okay, if you look at the shear flow, if the shear flow Q is equal to, for example, for our case, is equal to Vy, you have to take what? Izz and the first moment of area about the what? About the z-axis. You'll see that, yes or no? Right? Sorry, QZ, not AZ. I do apologize. Right? So the shear force direction, so this is the shear force direction is in the what? Shear force is in the what? Is in the y-axis, right? So you have to take your second moment of area about IZZ and the second and the first moment of area about QZ. I know some of you are like, oh shit, right? First moment, second moment of area, right? So the next one is when this is Q, and if this is equal to VZ, right? This will be equal to IYY multiplied by QY, right? Right? So I'll look. Let's look at ZZ now, right? Let's look at. So we look at VZ, right? Right. So the first moment of area is QY, and then the second moment of area is IYY. So that's why we have this formula over here. So VZ IYY QY. Okay. And if you look at shear now,